Welcome back to the channel. Today we're going to go over the construction of the Jerry Howe Farm Boy engine. This is a bar stock engine mostly, except for the flywheels. I did purchase castings for that from Martin Model. I'll put a link down in the description of that. So to start with, squared up some aluminum stock. This is the castings for the flywheels that I purchased from Martin Model. These are 6-inch flywheels. You could make these, the plans call to make these from cast iron, but I found that it was going to be cheaper to buy the flywheels than to purchase the cast iron. So here we are set up on the rotary table on the mill to start machining the frame, the rear frame. This is the start of the water hopper. So I've machined it out. There's where the cylinder goes, and the top is where the water will go in. This is back to the rear frame, so we're machining out the back part of it, which you'll see better later on as we get the frame together. Same machining out the rear frame, and this is set up on an angle plate. So it is machined at an angle, and it's set up on the horizontal mill. And this is the frame, loosely mocked up to give you an idea of what it's going to look like. So you can see the front water hopper, it'll have the cylinder in it, and then the middle part of the frame, and then the rear frame. This is a top view showing you the frame as it's put together. The front frame and the rear frame overlap, and they will eventually be screwed together, bolted together from the side. This is the start of the top of the water hopper cover, and this gets pressed into the top of the cylinder. Side view showing the same top of the water hopper. And this is where it goes in the top of the cylinder housing. This gets pressed into the top of it. So here we are drilling through the cylinder, and this is a really long drill and it's really small. So we're set up in the horizontal mill, and I got the drill bit in a collet so that I can stick out just a little bit of the drill bit at a time and then feed it out as I go. And then I've got it set up on an indexer because I got to drill 3 holes so that way I can rotate it and index for all 3 holes. And I got a expanding 5C collet holding it to the indexer. And it's worked really good to drill a really deep, small hole. So here you can see the 3 holes it was drilled, and the bolts that go through. This bolts this piece onto the front frame. This is the back side showing where the bolts come through and where it bolts to the frame. The hole in the center is where the cylinder will go. And this is it mocked back up with the water hopper top installed, and then the front cylinder mounted to the front frame. And I got 2 blocks on there to start the main caps for the rear. This is the cylinder. It was machined from cast iron, and it slips into the water hopper cylinder. Here's the cylinder installed. It slides in, and then there is an O-ring that seals the cylinder head to this. The cylinder head is what actually holds it in. Here's the cylinder head installed, just bolted onto the front of it, holding the cylinder on. This is where we bolted together the front frame and the rear frame. It's an overlapping joint. And then there's 5 bolts in there. Those are 256 size bolts, and they're countersunk, so they'll be covered with JB Weld. Here I'm starting to drill out the valve guide and valve cages, and I've got a parallel drill and an indicator on there so I can see how deep that I'm drilling it. Here I'm tramming in the vise, and I've got the cylinder head bolted to a plate at an angle, getting ready to drill out for the spark plug hole. Here's the spark plug hole drilled. It's drilled with a ball end mill, and then it's tapped, and I've got the valve guides and valve cages installed. This is the top of the cylinder head showing the valve guides. This is the cylinder head showing where it's bored out for the intake, where the intake goes into, the carburetor, and where the exhaust goes. Here's the cylinder head with the valve guides on it installed back on the front frame. Here's a rear view looking down the cylinder showing the valve guides and valve cages and where the spark plug will come into the combustion chamber. Here I'm drilling out the valve for the pin that holds it, and I've got the Dremel attached to the lathe and to the tool post. There's a neat attachment that allows you to put your Dremel onto there. This is a better view of it. So I'm drilling these valve guides, which are valves, which are stainless steel. I'm drilling them out for the pin that holds the retainer on. Here's the valve finished, and you can see how small the hole is. This is the valve. Just to give you an idea of scale, this is beside a number 632 screw. This is the valve before I cut it off. I left it onto the piece that I was machining it from. This makes it easier to lap the valve into the head so that you have something to hold on to. So you can lap it into the head, and then you can cut the valve off from that piece. Here's the valves finished and installed in the cylinder head. And the top of the cylinder head with the valves, and I've got some springs on there and the retainers and the pins. We're going to actually make the intake and exhaust springs for this, but I've got just some springs installed on there. And here's the cylinder head bolted back onto the front frame. And this is the start of the piston. This is the underside, machining it out for clearance for the connecting rod. This is the cylinder head with the spark plug installed. and the top side so you can see the recess for the spark plug, and it's large enough around it to get a socket on it. And this is the same 632 socket head cap screw beside the spark plug, just to give you an idea of how small it is. And the cylinder head installed back on the frame with the spark plug in it. And this is the exhaust rocker installed on the cylinder head. And a front view showing the exhaust valve rocker. And it's got a roller on the tip of it. This is the start of the connecting rod. I've got it bolted down to a fixture plate, and I'm machining out that pocket on the side. And this is the connecting rod finished with the bushing installed in the small end. And a side view of the connecting rod. And the piston installed on the connecting rod. And you'll notice there's one groove. This engine uses an O-ring instead of a cast iron ring. You could use a cast iron ring, but it calls for an O-ring. This is the start of the crankshaft. So I got a large piece of steel set up on the horizontal mill, and I'm starting to machine it down to size, just cleaning it up and getting it flat. Here we are cleaning it up. So I got the crankshaft installed on the lathe in the 4-jaw chuck, and it's offset. So I'm machining out the center throw first. And the finished crankshaft. Another view of the crankshaft. Here's the frame installed on an angle plate. So I'm set up to with the main bearing caps on there to start boring out for the crankshaft. This does get bushings installed in it. Another view of the frame boring it out for the crankshaft. Here we are set up in the horizontal mill to cut the keyway grooves in the crankshaft. I've got it set up in a collet block, in a 5C collet block. And you can see the T-cutter I've got there machining out the groove for the keyway. Here's the crankshaft after I've machined the keyway grooves on both sides. So this is the start of the muffler. This is my own design. It's machined as one piece to begin with, and then I drill 3 holes through it so that they all line up, and then it gets split in half, and then there's the inside gets machined out after that. Here's the muffler installed on the engine just to see what it's going to look like. And I think it turned out pretty good. Here's the engine mocked up with the exhaust installed and the flywheels on the crankshaft. And a close-up view of the exhaust installed. So I purchased this hand crank planer, which I'm not sure how old it is. It's got to be at least 100 plus years old. There's no maker's name on it. And it was in a little bit of rough shape. Here you can see where the tool goes and the adjustments for side to side and up and down. So I cleaned it up and got it in working order, and I'm going to use it to cut the keyways in the flywheels. As you can see in the video, I had the flywheels installed in a vise and on a sign plate, and it was angled up. These are actually tapered gib keys. So the keyway was cut in there on a taper. Here you can see the taper in the keyway. Here I'm set up to machine the gib keys, and I've got a 12-inch rule in there, and I know how much over 12 inches, how much rise I need. So there's a gauge block on one side that holds the steel rule up. So this sets it at the correct angle for the gib key. And the finished gib keys. Here they are installed on the engine, holding the flywheel on. You just tap them in with a hammer, and then you got to get behind them and punch them back out with a hammer.